Welcome to this tutorial about the basics of experiments in PsyToolkit. As always, all the information that you need is also on the PsyToolkit.org website, and that is where you can run your online experiments. Let's first address the question what we mean with PsyToolkit experiments. What are they? Well, it's a way to show stimuli, images, sounds, rectangles, shapes, videos, etc. to a participant. And it's a way that you can measure response speed. How quickly does somebody respond with the keyboard or the mouse? The PsyToolkit experiments can save reaction times, error rates, and other data to file. Experiments are written as scripts that you can write yourself. They have a dedicated scripting language that is a scripting language that is, in this case, simple, but is made specifically for psychological experiments. You can find ready-to-use experiment scripts on the PsyToolkit website. There are many of them. You can also write your own scripts from scratch, and we're going to do that in this tutorial. And all scripts can be written and run from the PsyToolkit website. So there's also an extensive library of free-to-use cognitive psychological experiments. Now, importantly, you do not need any other software to do this. It runs in your browser, and also you do not need to pay for using this website. It's a non-profit website that is specifically made for researchers in psychology and for students in psychology, but it's also used in other fields such as linguistics and music and even in the arts. If you go to the PsyToolkit website, I show here a browser. If you want to set up a new experiment, you first need to register an account. You go to web-based login, and if you have an account, it's very easy to set up. So you click this. Then you have you have a website. It will show you. I will show you that in a second. You first click create a new experiment, and then you get a box where you can enter the name of the experiment. For example, let's enter X. Then in that box you can enter code, and you save it. You could in principle upload image or sound files for more complex experiments than some of the ones we show here. There are 3 steps in writing an experiment. So first you write the script. Second, you compile. That means make it ready for the computer, check it on potential mistakes, and then run it. And I'm going to take you through these 3 steps now. So the first step is, as I showed before, you enter your PsyToolkit script code in a box. And that is the one thing that you actually need to learn how to do. At first it can look a little bit cryptic, but actually it is fairly straightforward, and there are many examples. You can always easily learn from examples. So once you've written your script, which I'm going to teach you how to do in this tutorial, you click compile, and that just means you tell the computer to make it ready and check if there are any mistakes in your script, like a spelling mistake. If everything goes well, it says successful compilation. You can now run the experiment. And then the third step is actually running it. You click this button, run experiment, and then in your browser you will see what happens. And let me quickly show you that. In the browser, so creating an experiment is quite easy. Just click create new experiment, select a name, for example X, create completely new experiment. I click this, and then I can enter my code here. You will see how to do this in this tutorial, but you can type something, and then once you're done, you click save. The fastest way to learn how to write this type of code is actually by looking at existing experiment scripts And another important tip is, in the beginning, you will get some error messages. It's easy to make a typo or to write something the wrong way. You might get lots of these messages if you write a complex script, but that's part of coding, and you make some mistakes, you correct, and you repeat that process until it works. That's actually how coding works, and you get the hang of that quite quickly. Now I'm going to show you a specific script. In a script, you first describe what happens in a trial. We call it a task, and you can choose your own name. Now let's just show quickly some of the code without going in all the details. We're going in all the details later on, but so a script can look like something like this. So here we have the description of one trial. So we tell the computer there is a key called the B key of the keyboard is being used. You show text to the screen, hello world. You check if a key is being pressed for, in this case, 2000 milliseconds. That's the maximum response time, and you save the data to a data output file. Don't worry, I'm going to show this later in more detail, but this is what it looks like. So you type these lines. I usually use a little bit indentation to make it clear. A task section describes what exactly happens in one trial of your task. Now, this is of course just showing hello world on the screen. It's not very interesting in terms of a psychological experiment, but it shows you how you show information and how you wait for a key response from the participant. Then you also have blocks. They look like something like this. In the block section, you see exactly what happens within one block of trials. In this case, we have something like a task list ended by the word end. And in between there, you say which task has to be done and how many times. So you say my task 10 times. You could, if you have more tasks, you can have more tasks, but let's not talk about that now. This is basically the simplest possible experiment where you show something on the screen and people respond, okay? These two blocks, they need to be separated by an empty line. But you can have as many tasks and blocks as you want. So this is a very, very basic script. Real tasks will be far more complex, of course, but this tutorial is really about getting you started, and if you understand the basics, then it's easy to extend it to something more complicated. The best way is to try this yourself now. Just try to type in something like you see here, and then compile it and run it. Does it work? Well, great. Make it a little bit difficult. Show a different text or something. Just play around with it, because ultimately you learn coding by doing. You just need to sit down and practice, practice, practice. I think within half a day you can become already reasonably good at it, that you can copy something, you understand what sort of like these things mean. Okay, let's now look at learning to write a more complicated script. We have two experimental conditions here. So we put those in a table. We have a right table, and I call it my table, and you can have two conditions. We have a condition, let's say call it left and right. And all we want to do in this experiment is show the word left on the left of the screen, the word right on the right of the screen. Minus 100 is the x coordinate where it comes on the screen. I will show you that in detail later, but basically the idea is here that you have in this table, you have two rows, and each row contains the information that's needed for the two different experimental conditions. What happens in PsyToolkit is that every time the task is being run, the computer can choose at random one of these two rows. So there are of course variations on how you can do this, but that's one way of doing it. Then you have your task. Again, let's call it my task, and we have some more complicated text here. I'm going to explain it in detail, but one of the things that's new here is that you have these @ signs. You can refer to the value of the table using the @ sign. Thus, @1, for example, here refers to the first column of whatever row the computer chose for the task trial. So we will look into that in detail later. But what's important here to understand is that there is a way to describe what conditions you have and to get that information into your trial. So the add one here tells the computer basically, take from the row that you've chosen for this trial, take the value of the first column. So if, say, the computer had chosen to do this first row, then the value of the first column is left, and it would show the word left, show text left at value -100. I'm going to show you that in more detail in a second, but that is sort of like a mechanism that you can use. That is actually a very important mechanism, so it's important that you understand that well, because the table is a very convenient way to work with conditions. But don't worry that you follow this in detail, because I'm going to explain some of the details of this trial later. But first I want to also show again that you have a block. That's fairly basic. So you have to have at least one block where you tell the computer how many trials there are, and we say, okay, we want to do this 10 times. Now let's have a quick look in the browser what this looks like. How you do this in the PsyToolkit system when you're in the browser. So as I said, you go to create new experiment and you enter a name here. Let's call this test, and I click create completely new experiment. Now you have here sort of like a command line. I can delete that, and I enter my code. I copy and paste in this case, and then I save it. I could in principle also add other files, like image files that I might use in my experiment. In this simple example, that's not the case. I scroll a little bit down to compile and run, and I click compile, and it says successful compilation. You can now run the experiment. When I do that, I see the experiment in action. Know that if you run an experiment online for participants, it looks similar, but you wouldn't see this back to experiment editor button, and the data would be saved within your survey. But otherwise it's the same. You click, and now we do this task. There are, I think, 10 trials where we see the word left or right on the screen, and once you've done that, at the end, PsyToolkit will show you the data if you want to see that, or you can save it. Now this again would not be shown when you collect data from online participants, but this is for when you design it, and you can see what the data file actually looks like. So later in the presentation this will be discussed, and you can go back to the experiment editor. But notice also that the output is in sort of like text format, in this case formatted within a table, but ultimately it's always text format, and here you have 2 numbers per trial. Now, okay, now that you've seen it, we're going to explain some of these details further, as I had promised before. First of all, this line show text at 1, at 2, 0, and clear 1. So basically, each time you show a stimulus, what's important to know is that that stimulus gets a number. In this case, the only stimulus we have is, there's only one, so we call that stimulus number 1. And we use that later to clear it from the screen. So you can clear a stimulus from the screen by using the word clear, followed by the number of the specific stimulus. You know, typically you have many stimuli in one trial, but they're always numbered, starting with 1 and then going up. And then clear 1, you can have clear 2, clear 3. That's just a way to referring to that stimulus. Otherwise, it's quite, there must be a way to do that. Alternatively to that, you can have clear -1, and that basically means the -1 clears the last stimulus shown, though even if this would not have been stimulus 1, clear -1 would still clear the thing that has been shown on the screen just before. So -2 would be 2 stimuli before, even though that couldn't happen here in this task because we have only one stimulus. The keys statement is quite important in PsyToolkit. Keys just tells the computer that there are only 2 keys in this task, namely the keys B and M of your keyboard. All other keys will be ignored by the computer. That's quite handy because sometimes people just press the wrong button for no reason at all. I mean, it just happens because, you know, that's easy to do, and we don't want that is being measured, so you can ignore that. And then the read key statement that checks if one of the 2 keys as specified in keys are being pressed. You tell read key what the correct key for this trial is. In this case, that is specified by the table. So if the computer has chosen to do, say, the second row for this trial, then the correct key would be 2, the second key in the keys line, and it would wait maximally 2000 milliseconds. After that, if the person doesn't respond within 2 seconds or 2000 milliseconds, that would be considered a timeout. You can also have something like a delay. A delay just does nothing, in this case for 1000 milliseconds or 1 second. Now, the last line here, save, is very important because you typically want to save information to the data file. This saves the reaction time and the status in this case. Yeah. For each trial, you will get 1 line in your output data file. In this case, there are 2 numbers on that line, the reaction time and the status. And I will explain what status is, but basically, if people are responding correctly, the status is 1. If people make a mistake, the status is 2. And if people do not respond at all, the status is 3. That is just a way that PsyToolkit codes response correctness. Now, let's run through the same script from the point of view of the computer. Here, see the computer with the keyboard. The B and the M keys are on here. This typical English layout. I think on most computers the B and the M are here. From the computer's point of view, the first thing that it will do is actually it does the block. It looks at how many tasks it has to do. And so it will see here, okay, I have to do my task 10 times. So then it goes to task, my task. And then it will know that there is actually a table associated with this. And then it says, okay, I will choose one of the 2 table rows at random. Let's say it takes the second one. I highlighted here in red. Then it will use these 3 values to replace the at values throughout the script. So at 1 will become the word write, at 2 will become the number 100, and at 3 will become the number 2. And later you will see what they actually do. But they will basically just replace these placeholders. The next thing is then it goes down. There will be 6 different instructions, and the first one is keys B, M, and that just then the computer knows, okay, there are only 2 keys that I should monitor. The B or the M will be pressed. All other keys is irrelevant. The computer is going to ignore those. But keys itself doesn't do anything. It just knows that this is a way to specify that you want to use these 2 keys. Nothing really happens then. This is the first time that something really happens. If you say show text and it shows the text, from placeholder 1. So I said that before. The word write at XY location 100 null 100 0. That is actually an XY coordinate. So 0 0 is the middle of the screen. So right is 100 pixels right from the screen center and 0 on the y-axis. Okay, there's a whole lesson about how to present stimuli and how this coordinate system works. Now, once that word is on the screen, the computer goes on with the next line, read key. Read key, and then it replaces this placeholder with number 2. And that means the computer now knows, okay, the key that is correct for this specific condition, for this trial, as specified in this table, is the second key from the keys line. So it knows key M would be correct, key B would be wrong. And it will look up to 2000 milliseconds or 2 seconds until the person presses one of these 2 buttons. Now let's imagine that the person does it correctly, presses M, and then, for example, say the response was 1243 milliseconds, just over 1 second. Then the computer will store that information, and it basically uses system variables like RT and status. I will explain those in a moment. Later you can save those. Once this is done, it says clear -1. Now, as explained before, clear -1 will just erase the last shown stimulus from the screen, so it will remove the word write. That's that. Then it says, okay, let's wait for 1 second or 1000 milliseconds. In time in PsyToolkit is always specified in milliseconds, so it waits 1 second. And then it saves these variables that were created by the read key instruction. RT is, it's an important variable, reaction time in milliseconds, and status. That is 1 for a correct response, 2 for a wrong response, and 3 for a timeout. I will show that again on another slide here. All right, and it saves that in the data file, and and then it goes on. It will save more numbers later on when it does more trials. But so the idea here is that it does this task, it does it 10 times, and for every trial it will save 2 numbers. So the reaction time and the status. But what is actually being saved in the task, you can specify that yourself. Typically you want more information. For example, what we did not save here is actually which of the 2 conditions is being used, and actually we could save the table row information as well. Look at the online lessons and tutorials and you will find that information. Now this is done in total 10 times. Now to explain a little bit the status, I just mentioned it. So status is it just used numerical codes. 1 is correct, 2 is wrong, 3 is timeout. There's a lot more than you can do with these scripts. Scripts can be simple like this one, but they can also be very sophisticated. You can make very smart experiments. There are many different types of stimuli that you can show. It's not just a text, but you can show images. That's actually quite useful. Rectangles, images, circles. You can even show videos. You can also have conditional if or while statements. If is very handy. So for example, if the participant makes a mistake, then just give a specific error message. There are lots of lessons, demonstrations, and examples for all PsyToolkit features. Go to the website. They're really easy to understand. Explanations, demonstrations. You learn from looking at these examples. Anyone can learn this. It takes a couple of hours to get the idea. Once you know the basics, you can extend and write great experiments. Here is a message from somebody on Twitter who wrote, I recently discovered PsyToolkit, a free online platform for programming experiments and surveys and collecting data. And I cannot recommend it highly enough. I programmed 2 tasks in 2 hours this morning despite not knowing the language. So that should give you some confidence. She also says there are no incomprehensible error messages, and you can present tasks and surveys in lots of different languages. That's right, PsyToolkit has a survey interface for all major world languages. There are currently, I think there are at least 40 languages available. Now, that's that. Enjoy.